Someone asked me the other day how strain imaging with feature tracking compares to strain imaging with DENS, which is the gold standard. And I thought that was an interesting question, so I thought I'd make a quick video showing how they compare. This is a patient with left bundle branch block. You can see here in the movie the asynchronous contraction of the interventricular septum. I'm going to click here on the lightning bolt and automatically segment the endocardial and epicardial contours. I'm going to go ahead and place an RV insertion point, and then I'm going to calculate the strain values automatically. While that's happening, take a look at the asynchronous contraction and see how well the endocardial and epicardial contours actually are drawn. The quality of the strain image is critically dependent on the quality of these contours. Now here you can see a map of what I'll show is circumferential strain for each of the 6 segments. And what I'm going to do is I'm going to focus in on just the lateral segments first. And what you can see is this upward motion in circumferential strain is actually due to stretching of the lateral wall as the septum contracts first. It's called pre-stretch. And then you can see the delayed contraction of the lateral wall here. Now if we compare that to the septal wall, you can actually see the strain pattern is quite different. That early contraction of the septal wall is terminated early and then carried on the contraction later by the lateral wall. Now I'm going to save this later for reference so we can compare to our DENS imaging. So I'm going to go here and select the DENS data, and I'm going to click on the automatic segmentation. Now for those of you who aren't familiar with DENS, it's a phase contrast technique. In fact, it's very similar to the phase contrast images that you acquire to quantify flow, except in this case, the phase contrast data is used to quantify the motion of the left ventricular myocardium. And if you know the motion of the left ventricular myocardium on a pixel by pixel basis, you can calculate how much that myocardium is actually stretching or contracting. And that can also give you strain data, but it's much less dependent on the endocardial and epicardial contours. And here you can see a video showing the strain data. And you can see, again, in this graph down here, the circumferential strain for each of the segments. I'm going to focus again on the lateral wall here. So let's take a look at those. You can see in purple and blue, again, that pre-stretch of the lateral wall along with the delayed contraction of the lateral wall, and a very different pattern than the septum, whose contraction is terminated early. I'm going to save that here. And now I'm going to go to the report, and we can compare the upper trace, which is done with feature tracking, and the lower case, which is done with DENS. You can see qualitatively the results are quite similar. However, the DENS data looks prettier because it's smoother, and you can see clearly why it's really the gold standard for assessing myocardial strain. Thank you very much.